Hi, I'm Ahmad, CEO of Causal Experts. At Causal Experts, we customize, enhance, and train open source robots to suit your business needs. We can also work with you to design and train robots from scratch. So there are types of robots, such as immobile robots, which are one or two robotic arms with 5, 6, or up to 13 degrees of freedom, and mobile robots, which are bipedal, quadrupedal, wheeled, crawling, swimming, jumping, flying, or different types. Tasks that robots can do nowadays or are learning to do are cleaning, sweeping, making a sandwich, picking and placing, cutting sushi, stacking shelves, fetching from shelves, folding shirts, etc. Methods of operation of robots are also varying. Some of them are teleoperation, where there is a AR, basically AR lens, AR virtual reality device, or there is a hand tracking device, and they use to basically capture the signals from teleoperator, and there is a TCP/IP and basically transferring this information via the teleoperation commands via the basically TCP/IP, and then these information are transferred to robots and then basically directly transferred to robotic operating system, and they translate into certain actions for the robot. There are pre-programmed robots which work on assembly line. There are autonomous robots, which are trained robots in virtual world or real world. These are robots equipped with vision, language, action models, can develop perception about the surroundings, link instructions to objects and actions through AI, and finally execute them. How do robots help your business? For example, cafes. They help with serving coffees, making sandwiches, wiping tables, loading coffee beans. And in grocery stores, they can help with stacking the shelves, moving boxes, fetching items. In retirement houses, there are robots that are called e-bar, elderly bodily assistance robot, and these are robots for body weight support, ambulation assistance, and fall catching without the use of a harness. So how do robots really operate? They use a variety of skills, and these include manipulation, which is robots' skills in handling objects for the desired output, perception, which is integration of sensors, algorithms, and computing processes that allow robots to interpret and understand the environment, enabling autonomous decision-making and actions. Localization mapping, which is localization is the process of determining an object's position and orientation within a known or mapped environment. Mapping is the process of creating a representation of the environment. And locomotion, kinematics. Locomotion refers to how robots move from one place to another. Kinematics deals with the geometry and movement of robotic mechanisms, including the joints and end effectors. Motion planning and trajectory optimization. Task and motion planning, and finally navigation, which is robots knowing the path from an origin to a destination. So training robots or robots learning, how it's done? It can be done in virtual environment using reinforcement learning, or it can be real-world training, imitation learning of demonstrated teleoperation. It's a teleoperation can be a source of data for imitation learning. A human operator might demonstrate a task to a robot through teleoperation, and this demonstration can then be used to train the robot's imitation learning algorithm. There are many other algorithms, and these include Okami, which is basically teaching humanoid robot manipulation skills through single video imitation, or learning from demonstrations by manually moving the robot, which is also called kinesthetic learning. And there are vision, language, actions that enable robots to understand instructions and perform tasks by integrating visual input, natural language, and robot actions. And there are variations of them, such as hamster, which is a generalization to vision, language, action models, in order to leverage cheaper off-domain data, such as action-free videos, hand-drawn sketches, or simulation data. So training robots are done in many different ways, and training using imitation learning needs various devices, such as augmented reality, virtual reality goggles, can be Microsoft HoloLens, Apple Vision Pro, or AI tools such as Meta Code Tracker, Molmo, or Llama 2 language models, visual encoder that fuses pre-trained features from Dino V2, which is a self-supervised image model, and Siglip, which is a vision language model. So many applications of LLMs and GPT and etc. for planning and perception within robots exist. That's why we call them embodied AI models, because they are basically AI within a physical body. And there are some operating systems for them, RT2, OpenVLA. Embodied AI is a crucial frontier in robotics, and it's capable of planning and executing action sequences for robots to accomplish long horizon tasks in physical environments. Embodied GPT, an end-to-end multimodal foundation model for embodied AI, empowering embodied agents with multimodal understanding and execution capabilities, and there are many other versions of them which are open source or closed source. Embodied chain of thought reasoning is used for vision language actions, in which we train vision language actions to perform multiple steps of reasoning about plans, subtasks, motions, and visually grounded features like object bounding boxes and end effector positions. Existing challenges in robotics are sim to real gap. Models trained in virtual environments using reinforcement learning do not perform as well in the real world environments because sizes and properties of the objects are not exact same. Shortage of training data is also another problem. While there is a lot of text for large language model training or image for vision language model or vision model training, there is relatively small amount of recorded actions for vision language action training. Thank you very much. Contact us and visit us at causalexperts.com. Thank you.